Yeah, am I audible?
Yes, sir.
Yeah, on
Yes,
screen,
sir.
you can see. You can see the screen.
Yes, sir.
Okay. Yeah, yeah. Very good morning. So the last lecture, I have identified two very important uh, continuous random variables, and among them we have learned that uniform random variable and its possible extension in the one dimension to two dimension and then n dimensional. Okay, and so and we have also seen that if you have uh, two random variables which are jointly distributed uniformly, okay, then they are independent and they are over the rectangle, right? Over the rectangle, then they are individual also independent, and both will go for both will define a uniform random variable individually. Okay, right. And then we have also tried to figure out the mean and variance of that uniform random variable. And the next important random variable is normal random variable, which is defined uh, by the notation. Okay, is you have, this is the notation n mu comma sigma square, so it has two parameters. One parameter is mu. Mu is denoting the mean of the random variable, and sigma square denotes the variance of the random variable x. And you know, it's the PDF is a special type of function, okay, which you have seen in some integration like error formula, okay, or maybe in the physics it is appearing more and more. Okay, so we know already the definition of the corresponding PDF of the normal and the variable. Now these exercises, okay, so exercise 1 is the standard one, and exercise 2 and exercise 3 will be the corollary of the example 1. Okay, exercise 1. What it says is you take any scalar multiple of a normal random variable. Scalar multiple means you are multiplying by a non-zero number we are talking about. Okay, then that will also a normal. And if you shift the normal random variable, shifting will not change the distribution. Okay, it will only change the mean and variance, and the corresponding density function will also be different based on this mean and this variance. However, that will also behave like a normal distribution. Okay, so means if you take, so it's very simple to observe that whenever b is any number between 0 to 1, there will be shrinking, and when you have b is more than 1, b is greater than 1, then you will have an expansion, okay, of that bell shaped curve. Okay, and x plus a, if you look at this, so this is a kind of shifting. Okay, so you have a, so bell shaped curve is shifting. So you know, you already aware about that, the normal random variable, when you try to look at the distribution, okay, it is going to be it's going to be a bell shaped curve, okay, which is going to be symmetric about the mean x equals to mu. Okay, let me tell you what it will impact x plus a. Okay, I think it is if you take, let's okay, let me okay, so you have this so let's say this is x equals to mu. So about this you have a bell shaped curve, right? Okay, so it is symmetric about the mean x equals to mu. That's what I want to say. Okay, so this is the x equals to mu. That's the bell shaped curve. Okay, now if you take a equals to minus mu. Okay, so for example I'm taking, so earlier is, then you have the new, suppose we are going to show, okay, suppose the exercise 1 is true, means this is also going to be normal, and again the distribution will be having the, will be the normal distribution. Okay, where mean of x is mu. So the mean of this now random variable x minus mu is going to be what? X minus mu will follow the normal distribution with mean. You can find out. So that's going to be expectation of x minus expectation of mu. Expectation of a constant is constant, so it's going to be mu minus mu, that is 0. Okay, and also you can identify the variance of x minus mu. That's going to be nothing but variance of x. Hope you remember. Okay, shifting will not change the variance, so that's going to be sigma square. So x minus mu will follow the normal distribution with mean 0 and variance is sigma square. So it's only shifting. Okay, so then new curve will be, you have, this is going to be the symmetric about the origin, this line x equals to 0. Okay, it's only shifting. Okay, my dying is not, maybe not that much correct, but I hope you understood. Okay, this well shaped curve is shifted to the origin. Okay, now if the exercise 1 we are still, we are able to prove. Okay, so our goal is to show this. Okay, so to show this we have already encountered this moment generating function. Okay, moment generating function of a normal random variable. Okay, so then you know moment generating function identifies the distribution uniquely. Okay, there is a result. Okay, that I'm not going to prove it, but we are going to take it as a thumb rule, you can say. Okay, so that this again is a part of, okay, let me I think here I am having, wait a minute, that's okay. So let me tell you what is going to be the distribution of this. So it's, I think finding the distribution of this is not that difficult task. Okay, so let me work out this. So you have x, you have the following information. X follows the normal distribution with mean mu and variance is sigma square. Okay, and now you have this y is equals to a plus bx. Okay, so there are various ways to deal with this. Okay, so it's very easy. I think it will be very easy to follow that expectation of y. You can find out that's going to be a plus b mu. It's very simple by following the linear property of the expectation. And variance of y is equals to b square time variance of x. That's going to be sigma square. Okay, that's very easy to follow. Now, if you go with the cumulative distribution function, Fy of y is equals to probability that y less than equals to y. Okay. Now this is equals to probability that y is a plus bx less than equals to y. Okay. That's equals to probability that I think you all will agree that bx is less than equals to y minus a. It will not change the influence the inequality. Now this is equals to, now this is equals to, I can look at it in the two ways. So here is b is a non-zero number. Okay, b is a non-zero. So it will be either greater than 0 or less than 0. Okay. So if it is greater than 0, it's going to be probability that x less than equals to y minus a by b if b is greater than 0, and is equals to probability that x greater than equals to y minus a by b if b is less than 0. Okay. Now this implies Fy of y is equals to, so the first, this one is nothing but Fx at y minus a by b if b is greater than 0, and it is going to be 1 minus, right? So 1 minus Fx of y minus a by b if b is less than 0. Okay, b equal to 0 is not right, because b is equal to 0 will give you the constant. Now I'm interested in the density function, and we know these derivatives will give you the density. What is that now? So this will imply what is Fy of y is equals to, so there are two cases. If b is greater than 0, the derivative of this with respect to y, so is going to be Fx y minus a by b time 1 by b. Okay, and here it's going to be minus 1 by b Fx at y minus a by b if b is less than 0. So b less than 0, you have here minus b. If b is greater than 0, it is plus b. And I think now you can combine both of them. Okay, Fy of y is equals to, I can write it's going to be 1 by mod b Fx at y minus a by b. Right? If b is greater than 0, mod b is b. If b is less than 0, b mod b value is minus b. Right? Now, if you what is this now? So this you can find out. Okay. So 1 upon square root of 2 pi sigma time mod b. Okay, mod 1 by mod b is multiple, so it's sitting here 1 by root 2 pi sigma exponential of minus, so fx of x was x minus mu by sigma square, right? So you have what is x is here is y minus a by b minus mu by sigma square, right? So this is equals to 1 upon square root of 2 pi sigma mod b exponential of, now you take the LCM, and what is here is now y minus a plus b mu divide by b sigma square. And now I hope now it is matching with your that mean is what, a plus b mu, and variance is, yes, I can write b sigma whole square as here is mod b sigma. Whether it's b or minus b doesn't matter. Okay. So whenever b is greater than 0, you have here is b sigma, and whenever b is less than 0, you have minus b sigma. Okay, so variance will be always positive. So okay, so it's very clear now from here that okay, this will imply that y will follow the normal distribution with mean a plus b mu, and variance is sigma square b square. Now, how does it help you is as follows. Now, if you take we are going to define the standard normal variate. Okay, standard normal variate. Now, if you take, so that's going to be identified z is equals to x minus mu by sigma. Okay, where x will follow the normal distribution with mean mu and standard deviation. So variance is sigma square. So okay, so it's where define z equals to this, where x follows the normal distribution with mean this. So now if you you can write this as ax plus b, where a is equals to 1 by sigma and b is equals to minus mu by sigma. So both are constants. Wait a minute. So ax plus b, right? Yeah. So instead of that, I will write as bx a plus bx, right? If we want to follow the previous notation. So here this is the b and this is your a. So a could be possibly 0 if mean is 0, it's 0. But standard deviation, you know, sigma is strictly greater than 0. So b is a non-zero number. Okay. B is a non-zero number. Okay, I'm just making it. So you have this is a plus bx with a equals to minus mu by sigma and b equals to 1 by sigma. Now, so by following the previous exercise, okay, z will follow. So from exercise 1 now, we get what? Z will follow the normal distribution with mean is a plus b mu and variance is sigma square b square, and that's equals to normal. A is a plus b mu. So a is minus mu by sigma plus b mu is mu by sigma. So minus mu by sigma plus mu by sigma is 0. And you know b square is 1 by sigma square. So sigma square times sigma 1 by sigma square is 1. So it's a normal distribution with mean 0 and standard deviation 1, or you can say variance is 1. Okay, so and what will be, so then z will follow the normal distribution with mean 0 and variance 1, and we are going to define its cumulative distribution function by the notation p of z. What we are going to define is like this: probability of z less than equals to z. Okay, this is the standard notation which many textbook follows. Okay, and its probability density function, what it will be is, you have is fz of z is equals to, you know, normal distribution is 1 by square root of 2 pi, sigma is 1 e to the power minus z square by 2, right? So I think we have forgotten here 1 by 2, right? We have forgotten this 1 by 2, right? We have forgotten this. Yeah. Yes, I have forgotten this one. Right. So this is going to be to the power minus z square by 2. And what is the means like nice thing about this standard normal variety, because we have the standard normal table, okay, which we can use, okay, for evaluation, okay, of some certain problem, okay, right. So we will now look after that, okay. Another important thing is phi of z is, you can also another property, okay, that can be noted, that phi of minus z is 1 minus phi of z, okay. Can you verify this? This very if you look at this for the standard normal variate, it's going to be you have a kind of bell shaped curve about the line x equals to 0, okay. Now what is phi of minus z is probability that, so you have, let's say here is minus z and here is you have is z. So what is phi of minus z? It's the area whatever has been covered from minus infinity to minus z. And what is phi of z? It's the area covered from, you have from the left, right, minus infinity to z. But total area is 1. So what it says, so 1 minus this, so 1 is what? What is the probability? This is probability of minus infinity to plus infinity, minus probability that it's less than. So it's going to be, if I say this is the area you want to cover, it's 1 minus phi of z will give you this area. So due to the symmetry, okay, due to the symmetry with respect to the line x equals to 0, both area value will be the same. Okay, so you can look at actual that integral as well, so you can change the limits, okay, you can use substitution method and you can prove it mathematically as well. Okay, so above the line x equals to 0, the area covered before minus z is same as the area covered after z. Okay, so because of this, so this is a phi of minus z and this is a 1 minus phi of z, so both will be the same. That's what it means. Okay, and that this relation is very much important because we have the standard normal table only for the positive line, okay, positive values. Okay, later on when you will talk about the confidence interval and all, okay, you will see the most of the values will lies between mu minus sigma to mu plus sigma. You will see the 90% the area will be covered by this interval, mu minus sigma to mu plus sigma in the confidence level. Okay, at the most you will go to the mu minus 3 sigma to mu plus 3 sigma, mu plus 2 sigma to mu minus 2 sigma to mu plus 2 sigma, then you have this mu plus mu minus 3 sigma to mu plus 3 sigma. So here is you have mu is 0 and sigma is 1. So you have minus 1 to 1 will cover the 90%, then you have minus 2 to 2, it will go till 93 or some 95%, and when you go with the minus 3 to 3, it is going to be almost 97%, you will see in the standard normal table itself. That area after that, it's almost negligible, you can see. Okay, right? So with this, all this stuff, okay, so let's, I think, work out with some examples. Okay, let's work out with some examples. Okay, so let's take this first example. Okay, so if x follows, because now I'm going to demonstrate you how to use the standard normal table. Okay, okay, so if x follows the normal distribution, okay, so it's given that x is following the normal distribution with mean 3 and variance is sigma square is 16. Okay, so it's very clear that from here you can notation, from the notation, if you work out, so mean is mu is 3 and sigma square is 16, and that will certainly implies mu equals to 3 and sigma equals to 4. See, we are standard deviation is always strictly greater than 0, so it's only 4. Okay, not minus 4. Now, what we are interested in, let's say we are interested in finding the probability that x less than 11. But not that we have only the information or only the table is available only for the random variable, which follows. So z follows normal distribution with 1, and z is equals to x minus mu by sigma. Okay, you keep in that mind. So what is your goal here? So to bring out the information in terms of this, how will you do that? You have to subtract mean and divide by standard deviation. Okay, so you have to do follow, so that means nothing should change. Okay, so to make it sure, so you have to do all the things on the simultaneously on the both side. So this is why here subtracting by mean 3 and divided by 4, so both the side is happy. Okay, so this is nothing but x minus 3 by 4 is less than, now you can evaluate this, 11 minus 3 is 8 by 4, that's going to be 2. And now this is nothing but the phi of 2, because see, equal to or does not equals to doesn't matter any sign. Okay, because the point probability, in the continuous case is 0. Okay, right? So this is going to be phi of 2. Okay, now I'm going to back, I'm going with this. Okay, let me okay, uh, uh, just a second. uh, Let me it's not working. Okay, uh, this table, wait a minute, let me, but it's not working. Wait, don't find any way. Yeah, yeah, fine. Now I want to understand this. I think now you are able to see this. Okay, now this is phi of x under the standard normal curve to the left of x. Now if you see, you have to watch the column and row. So this is the column where you have the values of x is 0, 0.1, 0.2, 0.3, 0.4, 0.5, and so on. Okay, you will see till 3 point something, till 4, I think so. Okay, now these, here is the member 0, 0.00, 0.01, 0.02, and so on till 0.09. Okay, now you can see I have seen, I've made out the circles. Okay, already. Okay, so let me tell this, what is this 0.5925987, this value. Okay, so this will correspond to this 0.2 row if you look at here, and 0.05. So 0.2 plus point, so first thing is 0.2 plus 0.05, that's going to be 0.05. 0.25. Okay, so you have to make addition. Okay, so 0.2 plus 0.05 is 0.25. Okay, and this is the value of P at that. Clear? Now let's see this red circle. Okay, it's sitting here. Okay, this 0.3, and it's with this 0.07. So 0.3 plus 0.07 is 0.37. So this is the value of P at 0.37. Okay, now if you look at this here, this circle 0.8, this is the 1.0, this is the row is for 1.0 and column is for 0.00. So this value is for P of 1.0, so 1 P of 1. Okay, now if you look at this circle 0.9573, okay, this is sitting in this row 1.7, where x value is 1.7 plus this 0.02, so it's 1.72, so it's going to be phi value at 1.7. Now what we are interested in phi of 2, so this is here. Okay, phi of 2 means x equals to 2 point something, right? 2.2 only, so 2 with this 0.00, so this is the value phi at 0.9772. And you can see as x is going towards 3, it is almost like 0.9993, so almost near to equals to 1. Okay, so you will see those statistics in your confidence level whenever you are going to learn it. Okay, right. So is there any doubt regarding here into learning this normal table? Yeah.
Sir,
Yes.
if any question is asked, this is the level of precision we will require. 2 digits after point.
2 digits after point means?
Matlab, like if you are asking any question regarding this in exam, like this
Huh.
table gives us accuracy till 2 digits after point for x. So this will
Yeah.
be enough, right?
Yes, 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 yes.
Okay.
Yeah. Okay.
Yes, sir.
Okay. So phi of 2 value is 0.9772. So this is fine. Now I'm interested in finding the probability that x greater than -1. Okay, now next I am interested in finding the probability that x greater than -1. Suppose I have let me have this here. I'm interested in probability that x greater than -1, and I have the information this x is follow the normal distribution with mean is 3 and the variance is 16. So mu equals to 3, sigma is 4. So I'm going to first make it in the for the case z equals to x minus mu by sigma. So that's going to be x minus 3 by 4. First my work down is for this. So probability that x minus 3 by 4 is greater than -1 minus 3 divided by 4, and that's going to be probability that x minus 3 by 4 is z greater than -4 by 4 is -1. Now, so this you can write as 1 minus probability that z less than equals to -1. Now this is equals to 1 minus phi of -1. But you know the standard table does not exist for negative values. So what you can do is you can have this is you can write as 1 minus phi of -1 as 1 minus phi of 1. So is equals to phi of 1. And it's very straightforward from here as well. Z greater than -1 will be same as probability that z less than equals to, right? Z is greater than -1. Okay, this is z greater than -1. Okay, so this is going to be same as probability that z less than equals to 1. It's coming out like this. Okay, so what you are interested in, phi of 1. So phi of 1 can be seen here. So 1 is here and 1, right? So 0.00 you have to see. So 0.8413. So this is the value, approximately 0.841. Okay. So idea is from the normal random variable, you have to turn out it to be in the for the standard normal one, and then you can use the normal table. Okay, right. Okay. Now the C part is, now can you work out this now? Okay. So probability that 2 less than x less than 7. So again you will repeat the same story here, x minus 3 by 4. Okay, and you have p of so this is going to be minus 0.25 left hand side, and right hand side is, you can work out, right, 1. Now when the continuous case, probability that a less than x less than b is equals to fx of b minus fx of a, that we have worked out already. So this is going to be equals to phi of 1 minus phi of minus 0.25. And now you are going to use the fact that phi of minus z is 1 minus phi of z. So it's going to be 1 minus phi of this. So it's going to be this phi of 1 plus phi of 0.25 minus 1. So you are supposed to find phi of 1. Just now we have just we have seen that table is going to be 0.8413. Now for 0.25 is going to be, so 0.2 plus 0.05, so it's going to be 0.5987. Okay, so it's going to be 0.5987 here, and minus 1 is going to be approximately, it's going to be 0.44. Okay, right. So let's take one other example. Okay, so the power W, so the power W dissipated in a resistor is proportional to the square of the voltage V. Okay, that is here W is equals to, given to you is R times V square. So R is a proportionality constant. Okay, so where R is a constant, proportionality constant. So R is given to you, R equals to 3, and it is also given to you that V follows, that voltage will follow the normal distribution with mean 6 and variation is 1. Okay, then find expectation of W and find probability of W greater than 120. So find out what is expectation of W. Okay, you do it. It's very simple. You have used the information of V. Yeah, what will be the answer?
111.
Yeah. So here it is. So expectation of W is equals to expectation of R times V square, and R is out, R is 3, and expectation of V square, how will you identify? By using the variance formula. So variance of x is nothing but expectation of x square minus mean square. So that's going to be used here. Okay. So I hope this can be done. Now, similarly, you can translate the information into, now see, V is, here is voltage, right? So V is a non-negative random variable. Okay. Now, if you look at here, so probability that W greater than 120 is nothing but probability that 3V square greater than 120. Now, probability that V square greater than 40, so 3 will get cancelled with 120, right? 40. Now, since V is a non-negative random variable, so it's certainly probability that V is greater than square root of 40. Okay. So this is going to be probability that now you have to translate, because V follows the normal distribution with some mean and some variance. Okay. You translate the information into now standard normal variate by subtracting with mean and dividing by standard deviation. So V minus 6 by 1, and if you work out with the table, okay, that will give you the final answer is 0.3700.
Sir, here wouldn't we consider the case of V less than minus under root of 40?
Pardon?
Sir, wouldn't we consider the case where V is less than or equal to minus under root of 40? Is
Less
less than
than
minus
equals
under root of,
to?
less than V is less than minus under root of 40.
How? V is a voltage. Voltage cannot be negative, right?
So voltage can be negative if the polarity of voltage is
Negative means?
opposite to our reference volt. If reference.
Okay. But I think this is a V square is greater than 40 means
Also, sir, as V is following the normal distribution, there is a probability that it takes negative values because the normal distribution exists at that point also.
pardon?
Sir,
Take
as
negative
V is
values.
following the normal distribution, there is a probability that V is taking negative values.
Yeah. Okay. Yeah. So we can take negative values. That's so sure. Okay. Probability that V square is greater than 40. Okay. So you are saying that we also take greater than minus root 40.
V less than and minus in the root of 40.
V less than.
Minus in the root 40, yes.
Just a second. Okay. So I can translate this information right now. Okay. So let me have this. So you have this is probability of W is greater than 120 is going to be is equals to probability that V square is greater than 40. This is what the information right now. Okay. Now this is going to be, I can write as 1 minus probability of V square less than equals to 40, right? Okay.
Yes, sir.
So this is going to be 1 minus probability that you have, this is p square is less than equals to 40 means v lies between minus root 40 less than equals to v less than equals to plus root 40, right?
Yes, sir.
Right. Now, so this is going to be 1 minus probability that this is going to be, you can now, you can say minus root 40 minus 6 by 1 less than equals to z less than equals to root 40 minus 6 by 1. Now, this is equals to 1 minus, so you have, this is going to be phi of root 40 minus 6 by 1, and we have minus phi of minus square root of 40 minus 6. 1 is outside. Now, this is equals to 1 minus phi of root 40 minus 6. So, minus minus plus phi of minus root 40 minus 6, and now this can be translated into, now this equals to 1 minus phi of square root of 40 minus 6 plus, I can write this as, because phi of minus z it is, okay, so plus 1 minus phi of z, so phi of root 40 plus 6. So this is going to be 2 minus phi of root 40 minus 6 minus phi of root 40 plus 6. Okay, clear? Now, what is the root 40? So what are the values now? Let me, yes, do anyone have the calculator?
Sir, 6.666.
Okay, just a second. Square root of 40.
6.666.
So square root of 40 is something like 6.32. Yes. Yeah.
Yes, sir,
And
6.32.
plus 6 is something like 12.32. So it is approximately 1. Okay. Right. So I think the 2 minus phi of this is something like 0.3245, and this is approximately 1. I must say, or means we can conclude it from the table later on. Let's say 12.3245. Okay. Now let's fix these values now. So 0.3245 now, right? So 0.3245 is sitting, so 0.3245. So what you can look for is 32, so 0.33 approximate, right? Okay, so that's the best value is can be taken. Okay, so 0.6293 can be taken now. This one is for that. And now you can look at here. So after 3.4 x value, it's almost 1, right? E of this. Okay, so that can be approximated. So you have just now you have is 0.6293. I think we are going to get the same answer only. Okay, so this is going to be 1 minus 0.6293 again, and that's going to be same as, right, means like 0.3707. Okay, so this is why it is not you can say that this is here it is not affecting. Why? Because of this root 40 plus 60 is lies far beyond than C number. Okay. Okay.
Yes.
So still okay. Okay. But it's better. Okay. Always to be safer side. So it's better this we have done this in this way. Okay. Right. Now let's take this another example which shows you that you can actually estimate the binomial distribution by using the normal distribution. Okay, normal distribution will be the good approximation for the binomial distribution whenever n is large. Okay, so here is this if you read this statement, let x be the number of times that a fair coin that is flipped 40 times lands on head. Find the probability that x equals to 20. So every time you are doing a Bernoulli trial, right, and you are getting head, that's a success. Getting failure, it's a fail. If getting tail, you are being failure. So getting head with probability is 0.2. We are taking a unbiased one. Okay, so that's we are understanding. So now you are doing that Bernoulli trial in 40 times with probability of success is 0.5. And you are interested in finding the probability of x equals to 20. So if you go with the binomial case, so it's going to be 40C20 times 0.5 to the power 20 times 0.5 to the power 20. If you recall, right, NCI p to the power I times 1 minus p to the power n minus I. Success to the power 20 and 1 minus p to the power 40 minus 20, that's again 20, so it's going to be this. And if you approximate by using the calculator, it's going to be 0.1254. Now this event x equals to 20, I can rewrite in the following form. I think it will not change anything because x is between, you have 19.5 to 20.5, it's sure, and it's not covering 19 and it's not nor covering the 21. So such type of corrections are known as continuity correction, means that you have an interval. Okay, now what is your objective now? So it's going to be probability of 19.5 less than x less than you have 20.5. So your objective is to approximate by using the continuous random variable, and which is very familiar to you is normal one, and we want to do that. Now you can look at the, so first of all you have to also keep in mind that standard normal table is available. Okay, means the table is available for standard normal random variable. So you have to make the mean is 0 and variance is 1. Okay, so you can find out what is the mean of the binomial random variable is n time p. If you recall, the mean of x is nothing but n time p, and a variance, that sigma square, is n time p time 1 minus p. If you recall from the binomial case, so n is 40, p is 0.5. Okay, so 0.5 into 0.5 is 0.25 into 40. Okay, so you have to grab this information to make this variable, treat this variable as a standard normal variables, because you have to subtract with mean and variance on the both sides. Okay, so if you do so, so you are going to have mean is here is 20 and variance is 10. Okay, so you are approximating x by normal distribution with mean is 20 and variance is 10. Okay, So now you are going to approximate. So you are going to subtract with mean and dividing by standard deviation. That's the square root of 10. And if you find the interval, that's going to be minus 0.16 less than x minus 20 by root 10 less than 0.16. So this is nothing but z now. Okay. And you know, a probability of a less than z less than b is phi of b minus phi of a. So it's going to be phi of 0.16 minus phi of minus 0.16. And now you use the fact that phi of minus z is 1 minus phi of z, and then you will find the 2 times phi of 0.16 minus 1. And now you can find out the point phi value at 0.16 from the normal table is 0.5636, and you substitute it and you see that value is 0.127. It's a good approximation because binomial is giving 0.1254, but it is evaluating 40C20. Okay, that's a very important thing, and it's having 0.5 to the power 20 and it's like 0.5 to the power 40. You are multiplying 5 by 40 times, and if you multiply a small number large number of time, it's going towards zero, right? Closer to zero. Okay, right? So it's a good approximation by normal. Let's take another example. Okay, yes.
Sir, can you please repeat that continuity correction step in the previous example?
Can
Please explain again that continuity correction step.
so continuity correction in such a way that you are not including any other value, right? X equals to 20 or x equals to 19, right? What is the previous value is 19. Another after 20 is 21 number of heads or 19 number of heads. So this interval neither containing 19 and nor containing 21. So most of the time people have distributed like you are subtracting half and adding half. Okay, this is what is known as the continuity correction.
Sir,
Means
if we
you are making the point. Okay, this either you take x equals to 20 or you take this 20 minus half less than x less than 20 plus half. Both are the same thing whenever you are working on the set of events.
yes, sir.
Yeah,
Sir, can we take 20 minus 1 by 4 and 20 plus 1 by 4?
yeah, that
That
also you
will
can take.
okay.
That also you can
That,
do. That is also a continuity correction.
okay, okay, sir. Understood, sir. Thank you, sir.
Okay, any smaller number 1 by 4, 1 by 3, 1 by 4, 1 by 6, anything. But in general, people use this. Okay, standard following is this. Okay, but you can take 1 by 4, 1 by 3, okay, and so on. Okay, or more closer to our 20, I think that may lead to more good approximation. I mean, I don't know about it, but you can check. Okay.
Yes, sir. And sir, the reason we are doing this is to convert to approximate x as a continuous random variable, right?
Yeah, and another important thing is here is it is very difficult to work with n equals to 40 because you have to evaluate this 40C20, and it is, you know how much it is difficult. 40 factorial divided by 20 factorial into 20 factorial.
Yes, sir. Yes, sir.
Okay, and you are multiplying 0.5 40 times. Okay,
Yes, yes.
so those are the things are challengeable, you can say. When you are taking the calculator, I don't know whether your calculator will calculate 40 factorial or not. If I do this, something like e to the power 47 something is coming into, it's very difficult. Okay, right.
Yes, yes, understood, sir. Thank you, sir.
Now let's take this example. The ideal size of a first year class at a particular college is 150 students. Okay, the college, knowing from past experience that on the average only 30% of those accepted for admission will actually attend. Uses a policy of approving the application of 450 students. So if you approve the policy of approving the application for 450 students, only 30% means like 150 students will attend and so on. So compute the probability that more than 150 first year students attend this college. So he is approving the application of 450 students. If you take X is the number of students that attend the class. Okay. So the number of students are 450. So each student will attend with the chances 30% is 0.3. So you can approximate this random variable by using the binomial also, and binomial will give you 450 n equals to 450 and p equals to 0.3, 30% the chance x, and you are interested in finding the probability that x greater than 150. So compute the probability that more than 150 first year students attend this college. So I don't think so anyone will take the idea of this binomial one. Say right, 450 c 151 plus 450 c 152, or 1 minus probability of x less than equals to 150 even is challengeable. So what is the alternate is you can also use the normal distribution. So for the normal, I already told you, you have to find out the mean and variance and approximate x now with a normal random variable with mean is n time p and variance, n time p time 1 minus p. Use that fact, okay, and that will give you the final answer. So if I do so, you have probability you are interested in x greater than 150. Okay, so you can have expectation of x equals to 135 for 15 to 0.3, and variance of x is n time p time q, or maybe 1 minus p 0.3 0.7 into 450, that's going to be 94.5. Okay, now x is strictly greater than 150 means it's going to be, you can also again you can assume that it's a continuity correction. Again, x greater than equals to 150.5, we are adding, right? We are going towards 151, so we are adding 0.5. You can add 0.4 0.25 0.333 and so on. Those things are also can be explored. Okay, now means you have the information like x is 130, expectation of x is 135 and variance is this. So you are trying to approximate x as normal with 135 is mean and a variance is a 94.5. So try to make it is a standard normal random variable x minus 135 divided by square root of 94.5 and use that fact now. Okay, you will get this. So this is going to be, you have a probability of z greater than equals to, so 1 minus probability of this is going to be phi of 1.5945. So it's almost 1.6. Okay, that you can approximate now by using the normal table. Okay, right. Now, okay, because this is the value, if you took that from the table, is going to be 0.9441 and the final answer is this. And now see how the life is simple now by using the normal. Okay, right. Okay, now this exercise will address very important thing, that if you take two random variables which are independent and normal, their sum will also be normal random variable. Not only that, you take any finitely many number of independent normal random variables, if you perform their sum, it will also be a normal random variable. So here you will, so again, See, if you recall, for the binomial case, right? If you have two independent random variable which are binomial, their sum will also a binomial random variable. What we have done there, we have taken the help of moment generating function. Here also you will take the help of moment generating function of normal random variable. Okay. So the way of finding the moment generating function is again to carefully handle that integral, because it's now involving exponential of something minus x minus mu by sigma whole square with 1 by 2. Okay, so you have to carefully substitute the things and you will get the final answer. Okay, so that evaluation I'm leaving as an exercise to you, and I'm giving you the final expression, which is going to be the moment generating function for normal random variable, so that you can later on match whether your integral value will either match with that or not. Okay, so here it is. So moment generating function for a normal random variable is this. Okay, you can verify that, okay, by solving this integral. So expectation of e to the power ty I can write down here. So integration minus infinity to infinity 1 upon square root of 2 pi sigma. Okay, you have e to the power t y or x, whatever. So tx, because exponential of minus 1 by 2 x minus mu by sigma whole square dx. So again, you have to carefully use, okay, substitution here. Okay, you have to make tx here inside, and you have to carefully substitute everything. Okay, and if you Google it out, the proof is also available online. Okay, right. Now, once you have the definition of this, and once you have this, okay, then you already know that moment generating function defines the distribution of a random variable uniquely. Okay, so you will follow again the similar process which you have done for the binomial case. So you have x1, x2, xn be an independent normal random variable such that xi follows, each one follows a normal with mean is mu I and variance is sigma I square. Define x equals to this. So it is very easy to find out what is the expectation of x is equals to in summation I equals to 1 to n expectation of xi. So that's going to be summation I equals to 1 to n mu I. Similarly, variance of x is equals to, since they are independent, is nothing but the summation of their variances. So summation I is equals to 1 to n sigma I square. Now you try to verify. Now this x equals to x1 plus x2 plus xn. Okay, use the fact that xi's are independent. Okay, and work out with the moment generating function of the random variable x. Okay, which is I'm giving here straightforward. So expectation of e to the power tx, that's x is x1 plus x2 plus and so on xn. Now you can write, so this is again, this is all till this step. Okay, everything is following in the similar fashion as we have done in the binomial case. We have used the fact that x and y are independent, then so is their function of x, functions are also independent. So x and y are independent, then g of x and h of y are also independent. Okay, and then expectation of g of x into h of y is expectation of g of x into expectation of h of y. Now you put down individual moment generating functions of x1, x2, xn respectively by following the definition. And then you know how these are the numbers, right? E to the power, so e to the power this plus this plus this and so on. Then if you summarize all the things, you will get mu value is summation of ui, and sigma square will be summation of sigma I square, and which is in line with the normal distribution with mean mu and variance sigma square. So you can certainly follow from here that X will follow the normal distribution with mean, mu and variance is sigma square. So sum of independent normal random variable is again a normal random variable. That is very important. But independence is necessary. Okay, right? Now the following. So after that, one example is there, so that you can look at in the recorded video. Okay, that is also explained there. Okay, so both the part are very well explained there, so that I'm not going to work out in the next class. So I'm going to open that recorded video. Okay, so this example you can work out in that from the recorded lecture. Okay, right. Thank you. If you have any question, you can ask.
So, when is the sim exam on Moodle is gonna when you taking?
This is going to be, I think, I'm going to check with the controller of examination. Is there any day which you are free from between 7th to 12th March or not? And if he says no, then I will make it on 13th of March. Okay?
Okay.
Yeah. I'm not going to bother you 2 consecutive exams. Okay, thank you.